Alright, welcome to a video from Math 1 looking at section 11.3 on proving parallel lines. So essentially this is the backwards section of section 11.2 where we talked about if you have two parallel lines intersected by a transversal, then you have all these different angles that are either congruent or supplementary. So this is the same idea, except we're writing it in the converse, which means we're flipping the hypothesis and the conclusion. Okay, so to begin with, we have the converse of the corresponding angles theorem. So we saw with the regular corresponding angles theorem that if we have our transversal, so remember a transversal is a line that intersects two other lines, these lines, and those two lines are parallel, then all pairs of corresponding angles, such as angle 2 and angle 6, would be congruent. So we're doing it backwards now. We don't know that the lines are parallel. Instead, let's say that we know that angle 2 is congruent to angle 6. Those are corresponding angles because they're in the same position. The conclusion would then be that the lines L and M are parallel. So if corresponding angles are congruent, then the lines are parallel. So to fill in the blanks of the theorem, if two lines in a transversal form corresponding angles that are congruent, then we can conclude that the lines are parallel. The two lines, not the transversal. Okay, so just to be clear, the two lines are parallel. The transversal is this blue line. Okay, so the rest of this is going to be very similar because alternate interior angles theorem said that if alternate interior angles were congruent, then the lines would be, or if the lines are parallel, then alternate interior angles would be congruent. So we're saying the backwards, which is if the alternate interior angles are congruent, so if two lines form a transversal form, alternate interior angles that are congruent, then the lines are parallel. Okay, so if angle 4 is congruent to angle 6, then line L is parallel to line M. Same idea. Remember that alternate interior angles are inside, and so this is the inside here, in between here, and they alternate sides of the transversal, which is this line, so they're on opposite sides. Okay, then we have these same side interior angles. The converse of the same side interior angle postulate says if two lines in a transversal form same side interior angles. Now this time, same side interior angles, you may recall, are not congruent. They are supplementary. So if we find that they are supplementary, which means they add up to 180, then the lines are parallel. So if the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees, then line L is parallel to M. Oops, that's a weird looking M. Let's fix that. So for example, if angle 3 is 110 and angle 6 is 70, then that adds up to 180 degrees. And the last one is the converse of the alternate exterior angles. So alternate exterior angles are like angle 1 and angle 7, and those would be congruent. If those are congruent, the lines are parallel. So if two lines in a transversal form alternate interior angles that are congruent, then the lines are parallel. So the conclusion is the same for every single one of these, but it begins different. So angle 1 congruent to angle 7, then L is parallel to M. Okay, so let's look at some examples. And often in these problems you're going to have more than just the two lines in the transversal. You're going to have multiple lines going on. And everything is going to look parallel. So you can't go by what it looks like. So the question says, decide if there's enough information to say that there are parallel lines. Then state which lines are parallel and justify your answer with one of the theorems. Okay, so let's start with our first example here. In the picture, we can see that we are given that this angle and this angle are congruent. So those are corresponding angles. If we use T as a transversal, it goes through line D and E. So S is actually not involved at all. Cover it up with your finger, ignore it, don't let it confuse you. It's not making those angles. It's not having any part of this. So since those are corresponding angles and they're congruent, yes, we can make a conclusion here. Specifically, we can conclude that D is parallel to E because of the converse of the corresponding angles theorem. I'm going to abbreviate here. Angles. Okay, let's take a look at example 2. Again, you want to focus on what lines are making those specific angles. Which one is the transversal? Which ones would be the parallel lines? Okay, so here we're given this angle is congruent to this angle. And so the transversal would be G. And the two lines are U and T. And those angles would be alternate exterior angles. So again, ignore H. So it's exterior because this is the inside between the two lines right here. And they're on the outside of that. And they're alternating the transversal sides. So this is a yes. And the two lines would be U and T are parallel because of the converse of the alternate exterior angles theorem. All right, example 3. So let's take a look at what kind of angles we have here. All right, we got this one right here, this one right here. Let's see if this thing, and you can extend it even though it's just a segment, is the transversal. These two lines would be the parallel ones, and these are alternate interior angles right here. So this is another yes. Notice this time that we're not using the little lowercase italic letters to name lines. We're going to have to name lines with the two letters. So the top line is line AB, and we put a little double arrow line over it. The bottom line is DC. It's supposed to be the parallel symbol. It looks a little crooked. And that is by the converse of the alternate interior angles theorem. All right, example 4. There's a lot going on here. Remember, you just kind of want to focus on the angles that you can see. Now, there are some markings on here that show some things are parallel, like that and that, but there might, so I'm just going to assume that those are given. We're not going to use those. But let's take a look at these angles that were given here. The measurements, we got 112 and 102 and 68. None of those are congruent, but are any of them supplementary? Let's see. 112 plus 68 is 180 degrees. 102, no. 102 plus 68 is 170, so we're just going to ignore the 102. So we have these angles here that are supplementary. That gives you some more parallel stuff. Okay, so I'm going to use this as a transversal, and the two lines that make those angles are KP and MN. So I'm ignoring LO and JQ and a bunch of other stuff. Okay, so I would say yes, KP is parallel to MN because of the oops, I forgot the word converse. That's important. Converse of the same side interior angles. I think this one's a postulate. Okay, so they're same side interior. They're on the same side of the transversal and they're on the inside. This is the interior. Okay, so there's some examples of how we could use the converse of these theorems and postulates to prove that lines are parallel.